Thank you, Christoph. My name is Kevin Grimes. Good afternoon. I am representing the PDS imaging node at JPL. And today I'm going to be going over the latest updates to our flagship search tool, the Image Atlas. So let's go ahead and just get into it. So I'm going to start with some background just about the Image Atlas and then the imaging node as a whole. And then the motivation for some of these changes and this new iteration of the service that we're working on. Finally getting into the Atlas and the updates we're making, the next step, and some references. And if you'd like to just download the slides, you can follow that link there, or just get it from Teams. All right, so starting with some background. So the PDS imaging node so it's colloquially known as the imaging node, but it stands for the Cartography and Imaging Sciences node of the Planetary Data System. It's one node located at two different facilities, USGS and JPL, and it's home to upwards of 1 petabyte of planetary digital archives spread across the two sites. We have a diverse collection of products, including from multiple different types of missions like landers, rovers, orbiters, and probes. And we archive both PDS-3 and PDS-4 data, mostly PDS-3 for now, but that'll change soon. And we have imagery, maps, and other types of products. And we also have over 1.2 million images in the archive spread out across 5 different missions that have been enhanced by ML processes. So here on the right is an example of some images that have been classified that make it easier to just find unique and different types of images within the archive. So the motivation, so what are we doing here? So the challenge is to enable users to effectively locate data that they need to do their research among that 1 petabyte of data. And this is partially solved with Atlas 3, which is the current version of the site. So what we offer with Atlas 3 is faceted search on hundreds of PDS-3 keywords from multiple different missions. So over a dozen different missions, you can search across all of them in a simple, like Amazon-like way using facets. And you can download the original products as well as their browse imagery and their label all from this site. There's also a report generator. The report generator will let you download metadata that's associated with the products you're searching for. And again, it's powered by ML in a lot of different places. For example, here, you can't really see the bounding boxes on this, but this image is an example of a high-rise product that was classified by one of the some of the team members at JPL, and it identified some craters and impact ejecta, and labeled it here. And so we have that incorporated into the Atlas. So, so it's great, but there are some improvements that we want. So first of all, there's availability and scalability concerns. The current site is not really built to scale, and it gets hit hard sometimes, and it goes down, which is never fun. Security and performance expectations. So a lot of the software and the technologies that were used are pretty outdated, and they have not been updated regularly with security patches and things. And also a big one is that downloading lots of data at once is a hassle. So even if you're able to find the data that you need, actually downloading it is not always easy. It doesn't work on a phone. Don't try it. It's not going to work. You might be able to make it work on an iPad, but the phone, it's rough. And it was built nearly a decade ago using technologies that have since become outdated, and that's in both aesthetics and usability, and also in security, as I mentioned. So introducing Atlas 4. So Atlas 4 is a single-page application using several different modern technologies. The design is inspired by Material UI. It doesn't adhere exactly to it, but it's certainly inspired. It's mobile friendly. You can have a great experience on whatever device you're using, whatever screen size. There's enhanced filtering. I'll show an example. Improved geospatial search support using some new integrations. expanded file exploration functionalities, a streamlined download process, and tighter integration with machine learning classifiers. So let's just get into a couple examples of these. So one of the big changes is that filters now are addable. So on the old Atlas, there would be on the sidebar just a list of hundreds, close to 1,000 different facets and filters you can choose from. And that can be kind of overwhelming if you don't really know what you're looking for, to just have to scroll through all these. So now we're making the facets addable. So there's a form that you go and you add the facets that you really care about, and then from that facet selection, you can then choose what you want to search for. Also, we categorize the facets. So there's a few examples here of time, grouping facets by time, by spatial, by lighting. You can kind of compare that to, like, at Amazon, you would have groupings by, men's clothing or video games or anything else, similar type of grouping. And then there's supporting documentation for fields parsed from PDS archival documentation. So this was a big thing because a lot of these fields, end users don't necessarily know what they are and what they mean, but we were able to parse the documentation that's included with PDS3 and PDS4 bundles and volumes, and get that information about those fields and incorporate that into the user interface. So that really helps users understand what these fields are. And also, we have totally reworked how the searching happens behind the scenes. Previously, you would just hit a Apache Solr endpoint. Now there's a brand new API service deployed in AWS that uses several different technologies, Lambda, API Gateway, and then also Elasticsearch behind the scenes. So this is another really cool thing. So geospatial search has been completely improved and redone by integrating with CartoCosmos, which I'm sure many of you are familiar with. It supports drawing bounding box, 30 different planetary bodies, polar projections, and a whole suite of base maps and layers for each. So in this example, you can see this is a base map, or a base map, and there's a border, a bounding box drawn, and this is a way to select a bunch of images within this region. And then you can see the yellow dots with no numbers in them are actual images, and then the ones that have numbers in them represent a cluster of images. And if you were to zoom in on that cluster, you would see it expand into multiple different images. This really gives a unique way for users to have some sort of context for the images that they're looking at. Okay, and then another thing that's really new is the file directory view. So previously, if a user wanted to look at the data, look at their data within the context of the PDS3 volume or the PDS4 bundle, they would have to go through this Apache directory listing, which is like very, it's not easy to navigate. You have to click through folders, and it's not good. But now we have this dynamic view of the archive, and that uses our custom data access API behind the scenes. And what that does is it actually abstracts away the location of these files. So in this example, actually, each of these missions, some of that was pointing to data stored at JPL. Other data was stored in an S3 bucket. And so all of that is abstracted away to the end user. All they see is they just see this listing, and they can go and play with the data or get the data without really caring where it's located. And we've added some simple navigation, filtering, sorting, and search to this, just to make it easier to just navigate the data if you don't want to go through the searching interface. Another thing we added is a shopping cart. So again, going along with the Amazon metaphor, as you're going through and browsing your images, suppose you find some that you want to download. You don't have to download them right away. You can just add it to your cart. You can also save entire queries. So if you're searching for hundreds or thousands of images, instead of clicking one by one, you can just add the entire query to your cart. And then once you're done and you want to go check out, you can go and head to your cart and remove anything you don't care about anymore, and then start the download. And what it'll do is it'll stream to a zip file on the client's machine, so you don't have to install anything. It'll just stream right to the file. You can pause and resume the transfer, so if you're downloading a bunch of data and you need to, your laptop starts to die or something, you can pause it and resume it later. It'll also report the status of how far along it is. You can see a percentage there, and then when you hover over it, it'll show how many products have been downloaded and how many are left. And it'll also store a JSON manifest. So once you've actually downloaded the files, you can see a manifest of everything that was downloaded. And then one other thing is the image pages. So previously, images were not really treated as first-class citizens in the image atlas, but now each image has its own page, which means that you can share that image to other people and they'll have a permanent link to that image. You can zoom in on it, you can pan it, and there's layers you can toggle on and off from this view, and also you can see the label and the image at the same time now. And also there is this interactive label with a feedback loop, so if you click on any of these fields on the side, it'll actually add that field to your search. And so, for example, if you're looking at an image and you say, hey, I want to look at other images that have this particular azimuth clock angle, you can add that to your search and continue on from there. Yeah, so it's Atlas, a couple other just assorted features. It's mobile friendly, has all that neat help information, closer integration with machine learning classifiers, highly extensible, virtualized lazy loaded scrolling, and it has a shared design system and tighter relationship with the main PDS imaging site, and most importantly, it has a light and a dark mode. So I know a lot of people like dark modes, so yeah, we got that. And then another cool thing is advanced search. So we've basically leveraged, because the Atlas search API, it's very similar to the Lucene Elasticsearch syntax. And so we're able to kind of leverage some libraries that give you autocomplete when you're filling out an advanced search. So if you really want to create a crazy custom search, you can do that, and then there's autocomplete that'll help you build that query. So on the left there, that's an example of searching for fields. And then on the right, this is an example of searching for facets that are valid candidates for that field. All right, so next steps. So what we want to do is we want to make sure that we support all data from Atlas 3. So I mentioned Atlas 3 has over a dozen different missions. We want to make sure that all of that is carried over into the new site. Also, we want to fully integrate with the PDS API. So this is something being worked on by the engineering node, which Jordan mentioned yesterday. And we want to integrate with that as much as we can. Additionally, we want to integrate DMUD. And this is a really neat type of classifier. And what it does basically is given a given image among a data set, how unique or novel is that particular image? And so you can see here, this is an example of DMUD that was run against the first several sols of the InSight mission. And what it did was it just returned a whole bunch of different looking images, including a black image, which is technically novel. That was before the lens cap came off. It's technically novel. And you can imagine using this to create some sort of like smart sorting, or like a sort by novelty sort of thing. So instead of just sorting by time, where a lot of images can be redundant because spacecraft tend to take a lot of the same stuff, same images over and over again, this will potentially give users a more diverse experience. And also we want to generate tiled versions of our browse imagery. So using that panning and zooming, it's ready for some DZI tiled images to just make things even more efficient. And it's coming early FY23, so in the next couple of months, definitely come check us out. And it should be ready for you to play with, and we would love to have some feedback. So with that, I am happy to take any questions. Thank you.
Many thanks, Kevin. Very nice. Any questions for Kevin? No problem. No.
Oh, no.
It's good to have questions, so don't worry.
Yeah, it looks very cool. I'm sure there's a lot of stuff going on that you didn't have time to present. I'm wondering, when I throw a bunch of products into a shopping cart, is there a little checkbox that says, and give me the relevant documents, the product sys and that kind of thing?
So not yet, but that is a great suggestion. That is something that we had thought about, being able to download. Actually, a previous presentation mentioned doing something similar. And I really like that idea of being able to say, like, hey, so given this image, go download any like linked files in there, including documentation or other things. So that's something we're definitely going to look at. Not supported now, but yeah, we'll look at it.
And then one other was in the image view where you say you get to be a first-class citizen now.
Mm-hmm.
Do you expect to also include like a label view where somebody can see like the label as it is and not boxed out or passed out?
Yes. So the example that I gave was a PDS3 label, and so it wasn't terribly. But yeah, for like the XML labels for PDS4, we do preserve the PDS4 structure, and so it will look just like the label is the idea. And then, of course, you can always go and open from there. There will be a link to open the corresponding label from there. Mm-hmm.
Yeah. Ashish.
Hi, this is Ashish Mahabal from Caltech. So what kind of images does DMUD work on, and how does it create its first model?
I am not qualified to answer that question, unfortunately. Kiri, you want to take a swing at that?
You were asking about the DMUD model? Yeah, so it's a generic algorithm that does a SVD-based decomposition of whatever input you gave it, whatever data set, and then ranks them by reconstruction error. And so in that case, we were working with the Insight images using a feature vector representation that was extracted by a neural network and doing the decomposition on that representation.
I have a question myself.
Mm-hmm.
So in this new faceted search where you can actually select or unselect the filters, so can a user, when he or she comes back to the session later on, I mean, can you actually store your configuration of the filters that you have?
Yes, so there is the link, the URL will capture whatever filters you've selected. So you can refresh the page, and the first thing it'll do is it'll read the URL, and if any filters or anything is set in there, it'll go and reapply that to your session. So yeah, it should persist. You can share it with people, open it on a different computer, and it'll be the same experience.
Okay, so you can, I mean, the URL is being built according to the filters that you have.
That's correct.
Okay, so if you store that, then you can come back.
Mm-hmm.
Excellent. Any other questions?
Yeah, I do the same thing with URLs. How about, is it a problem that lid vids can be super duper long? Does that throw the URL off? If that's somebody's filters.
Yeah, that's an interesting question. Yeah, I mean, so URLs can be something like 200 characters long by default, and I think you can exceed that if you need to. That hasn't been a problem yet, but that's definitely something we'll look out for as we continue for testing. We might need to have some sort of hashing of that so that we can, not run into that limit.
Okay, so I think it's going to be time. Well, let's thank Kevin again.
Thank you.